JK flip-flop. Right? Today we are going to design a 3-bit synchronous up counter using T flip-flop. So what are the steps involved in designing this up counter? So what is the first step?
Decide the number of flip-flop and the type of flip-flop.
Yes, first we have to decide the number of flip-flops and the type of flip-flop. And what is step 2?
Step 2, to write the excitation table for T flip-flop.
Yes. So we are good. We are going to design using T flip-flop, and so first we have to write the general excitation table for T flip-flop. Next, what is step 3?
To draw the state diagram.
To draw the state diagram. Very good. So if it is a 3-bit synchronous counter, then how many states will be there? 8 states will be there, 0 to 7. So we will be drawing a state diagram with 8 states. Right? What is the next step?
To draw the excitation table for the circuit.
Louder please.
To draw the excitation table for the circuit.
Yes. So we are going to design a circuit. Very good, Sina. We are going to design a circuit which counts from 0 to 7 using a T flip-flop. For that we have to draw an excitation table, right? Already we have a common excitation table for T flip-flop. Now with that as the base, we will be drawing another excitation table for the state diagram which with our requirement. Okay. What is the next step?
To draw the camera and find Boolean expression.
Yes, very good. So this is step 5, right? So we have to, after drawing the excitation table for the circuit, we will be drawing the K-map, right? What for we have to draw the K-map? To find the Boolean expression in order to design the circuit. Once after finding the Boolean expression, what will be the next step? The last step, step 6. Step 6. Anyone? To draw the circuit diagram. Okay? Good. This is a 3-bit counter. Number of flip-flops is 3. Suppose if it is a 2-bit counter, number of flip-flops will be 2, right? And T flip-flop, because the question itself has been mentioned. If it is not mentioned in the question, you can choose any flip-flop to design. Okay? Then step 2. Shivaraj. Step 2. What is step 2? To draw the excitation table of T flip-flop. You have all the states, right? All the 8 states with you. Now step 3 is to draw the state diagram, right? What is the first state? What is the first state? How many states are there? 0, 0, 0 to 1, 1, 1, right? 0 to 7, altogether 8 states. Since it is 0, 0, 0, okay, right? And since it is 3-bit, actually the count will be from 0, 0, 0, 1, 0, 0, 2, 3, 4, 5, 6 and 7, right? See, as per this, if this is the present state, what should be the next state? So what should be the next state? Whose next state? You can stick the next state here. Here. So this is the next state. So see, if 0, 0, 0 is the present state, if this is is the present state, then next state will be 0, 0, 1. Okay, so this is known as the state diagram. For any practical application, you can draw state diagram. Right? You will be having different states whenever you consider an action. Let it be control systems or let it be machines or whatever it is. Let it be a real-time problem, the output from the sensors or whatever it is. Right? We have different states or different cases. Right? We will be considering those states or cases as states. Right? And we will be drawing them, or you can call it as a flow diagram too. Right? So see, if 0, 0 is the present state, 0, 0, 1 is the next state. So I am writing here, if 0, 0 is the present state, 0, 0, 1 is the next state. Right? This is the next state. And if 0, 0, 1 is the present state, what will be the next state? Yes, 0, 1, 0. Who is the next state now? 0, 1, 0 is the next state. So if 0, 0, 1 is the present state, what is the next state? 0, 1, 0. So 0, 1, 0 is the next state. Okay. Then what is the next state? If 0, 1, 0 is the present state, what is the next state? Who is the next state? 0, 1, 1 is the next state. So 0, 1, 1 is the next state. So this is the next state. Now see, if 0, 1, 1 is the present state, who will be the next state? Who is the next state? So 1, 0, 0 will be the next state. So this is the next state. Okay. And then if 1, 0, 0 is the present state, who will be the next state? 1, 0, 1 will be the next state. So 1, 0, 1 will be the next state. Leave space for two more states. Paste here. Okay. Now this is the next state. See, if 1, 0, 1 is the present state, if 1, 0, 1 is the present state, who will be the next state? 1, 1, 0 will be the present state. Sorry, next state. If 1, 1, 0 is the present state, now this becomes the present state, am I right? Right? If this is the present state, who will be the next state? See, this person will be the next state. Who will be the next state? 1, 1, 1 will be the next state. Yes, very good. So this is the next state. Now if 1, 1, 1 is the present state, who will be the next state? Altogether, how many states are here? 1, 2, 3, 4, 5, 6, 7, 8. So it's over, right? We do not have more states. And if it is the present state, what is the next state? 0, 0, 1. So 0, 0, 0 is the next state. Okay? So this is known as the state diagram, representing all the states. And from the state diagram, we will be drawing the excitation table. Right? So if 0, 0 is the present state, next state is 0, 0, 1. So next state is 0, 0, 1. Right? If this is the present state, this is the next state. Okay? Yes? Now after completion of this, what we have to draw? Actually, this is the step 4 is the excitation table for my required circuit. Okay? So my required circuit is design a counter which counts from 0 to 7 using T flip-flop. Right? So I am going to use the basic excitation table for the T flip-flop. Right? So see, let me consider this, this is QC, that is the present state of the third C. This is A, B, C mentions the name of the flip-flop. Let me take, this is A is the first T flip-flop because we need 3 flip-flops, right? This is the second T flip-flop and this is the third T flip-flop, right? This is the next state of those flip-flops respectively. Okay, now see, if you consider this as the present state, then QC star will be the next state. Right? If this is my present state and this is my next state, then what will be the value of T? See, present state is 0, next state is 0. Right? So if present state is 0 and next state, let me mention here a star. So if Qn is 0 and Q star is Q then T will be 0, right? So see, here it is QC, so across TC I will be mentioning as 0. Okay. Now if this is 0, present state is 0, next state is 0, we know it is 0. If present state is here again 0 and 0, it is 0. If the present state is 0, look here, if the present state is 0 and the next state is 1, what is the value from the excitation table? See, second state shows that it is. Okay. Similarly, we have to fill all the other values. Again, 1 and 1, if it is 1 and 1, then the value is 0. If it is 1 and 1, again it is 0. If it is 1 and 1, again it is 0. If it is 1 and 1 and 0, what is the value? 1. Right? So I fill for TC. Similarly, I have to fill for TB and TA. For TB, if you want to fill, you have to consider QB and QB star. Okay? If you want to fill for TA, you have to consider QA and QA star. Okay? Can you fill this? Yeah. Harish. TA, can you start? Draw the circuit diagram. So listen here, 3 flip-flops, right? So I am drawing the 3 flip-flops. So 1, 2 and 3 flip-flops. Okay, so this is T flip-flop, right? So I will be having only one output. Let me consider as TA, TB and TC, right? And outputs as usual we will be having QA and here we will be having QA dash. So this is QB and QB dash. That is the inverted. See, QB, QA dash and star is different. In the program you have used star, that is next state, right? Here this is dash, that is QC and QC dash. Okay, this is a synchronous counter. What does it mean? Since it's a synchronous counter, clock should be given simultaneously to all the flip-flops. So I am giving clock. See, what is the meaning of using this arrow mark? I am telling that the clock which I am using is an edge-triggered clock. Okay, so I am giving clocks to all the flip-flops simultaneously. That is why we say this is synchronous counter. Okay, now see, I have taken the outputs and the inputs. Now I have to give connection to the inputs. What about TA? What is the input for T? This is TA, right? What is the input for TA? It is 1, right? So logic 1. For TA, simply we will be giving logic 1 as the input. For TB, QA is the input. So here comes the QA and directly connect QA to TV. Okay. So if you want to tap output, because we need to count, right? You can tap QA from this point. Okay. And what is TC? QB and QA, right? Here I have QA, right? Here I have QB. Give these two to an AND gate and give this output to as input to TC, right? So at this point it is QA and QB. QA and QB is equal to TC, right? And if you want to generate the output QB, here you can tap QB at this point and QC at this point, because if you want to count, you need this QB, QA and QCS outputs, right, to the LED. So you can connect these points to LED, and this is the circuit. So all these are T flip-flops. Don't forget to mention what kind of flip-flop it is. All these are T flip-flop. So this is a circuit which we have designed. Or this, using this circuit, I can count the numbers from 0 to 7 using T flip-flop. Okay.